Today we will solve the problem 2.42 of Griffith 4th edition Introduction to Electrodynamics. The problem 2.42 is a metal sphere of radius r carries a total charge q. What is the force of repulsion between northern hemisphere and the southern hemisphere? We have divided into two hemisphere, one northern and the other one is southern. So, what is the repulsive force between them? You know very well that the electric field inside this sphere is zero, and the electric field outside the sphere is equal to 1 over 4 pi epsilon naught q divided by r squared r cat. So, this is the direction r cat along the direction r cat, and you have a electric field E here, E, and this is your z axis, and the angle between them is theta. So now the what is the average electric field? Average electric field, we have dividing this into two hemisphere. The average is 1 over 2, half of the total sphere. That is 1 over 2 and this electric field. 1 over 4 pi epsilon naught q divided by r squared r cat. Then what is sigma? Charge per unit area, which is equal to the total charge divided by the area 4 pi capital R square. Now, what is the force per unit area? Remember that this is charge per unit area. So, force is equal to, from Lorentz force, it is equal to charge into electric field. So this is the force. Here we are taking sigma, that is charge per unit area multiplied by this average electric field. That means this is force per unit area. Then we have to take force on total area. So force per unit area is equal to sigma multiplied by E average. If you multiply this and this, you have here except 2 epsilon naught, everything is common for both. That is q divided by 4 pi r squared. Here also uh, q divided by 4 pi r squared. You take 1 over 2 epsilon naught out. Then you square this q pi 4 pi r squared whole squared r cat. Now we have to find the force along this z direction. So that is z cat multiplied by r cat, unit vector. Both are unit vector. Unit vector along z direction, unit vector along r direction. So which is equal to cos theta. This angle is theta, so this will be equal to cos theta. Uh, so force per unit area is equal to sigma times E average, which is equal to 1 over 2 epsilon naught q divided by 4 pi r squared whole squared. This z dot r dot is cos theta. Then we will move further. We know the force is equal to q into E, but here we are taking sigma, that is charge per unit area. So this small fz is equal to the force at a small area TA. So which is equal to 1 over 2 epsilon naught q divided by 4 pi r squared whole squared cos theta. Now what is the total force? Total force capital Fz is equal to integral of Fz. Fz small fz refers to force due to a small area dA. So if you integrate, you will get total force. If you integrate with respect to TA, you will get total force. Now Fz is equal to 1 over 4 pi epsilon naught q divided by 4 pi r squared whole square. Since all these terms are constant, I am taking out of the integral. Then it will become integral cos theta TA. For cylindrical coordinate system, this TA is equal to capital R squared sin theta t theta t pi. If it is r is variable, then this will become small r squared dr. That is triple integral. Now, since r squared is fixed, you have double integral. One with theta and other with pi. So one with theta and other with pi. So if you integrate t pi, you will get 2 pi. And you take this r square also constant outside, 2 pi r square. That's what I have done. Now you square this. If you square this, uh, you will get q squared divided by 4 squared is 16 pi squared r power 4, and you have here 2 pi r squared, and you are integrating 0 to pi by 2. Remember that you are integrating 0 to pi by 2, not pi, because it's a hemisphere. If it is a full sphere, you will integrate between 0 to pi. Here, since it's a hemisphere, you are taking the limit pi by 2. Now you can cancel some of the term outside. So you can cancel this 2 with this 2. 2 will get cancelled. And next, this pi will get cancelled with this pi squared, will become pi, simply pi. And this r squared will get cancelled by this r cube, which will become r squared here. So you can take this 1 over epsilon naught. Here you have q squared 16 pi r squared, and 2 pi r squared already got cancelled. Then you know the cos theta multiplied by sin theta. Cos theta sin theta is equal to 1 over 2 sin 2 theta. Of course, you have t theta. Now you have to carry out this integral. Now we got Fz is equal to 1 over epsilon naught q squared over 16 pi r squared, and this integral. Now we have to carry out this integral. Before that, you bring 1 over 2 outside the integral. Then this will become q squared over 32 pi square pi r squared, because 2 into 16, 32. Then you have to integrate only sine 2 theta t theta with respect to theta. If you integrate to sine theta, you will get minus cos theta. And if you integrate again with respect to theta, you will get 2, 1 over 2. So this integral is minus 1 over 2 cos 2 theta. Now you have to apply the limit 0 to pi by 2. Upper limit is pi by 2, and lower limit is 0. So now you take minus half outside, and if you apply upper limit, cos 2 theta, that is theta is pi by 2, will become cos pi. This is cos pi, and minus cos 0. Lower limit is 0, cos 0. So which will become minus of cos pi is minus 1, and cos 0 is 1, 1 minus 1. So you will get minus of multiplied by minus 2. So 2 2 will get cancelled, and minus 1 minus 1 will become plus 1. So the value of this integral after applying the limit is equal to 1. Then the f z is equal to q squared. I brought this epsilon naught after pi. So 32 pi epsilon naught r square. This is the force between the northern hemisphere and southern hemisphere. Thank you very much for watching my video and supporting me continuously. Thank you very much.